everyone. Thank you for joining our webinar today. We're so excited to have Ivan Lopez here, and he is going to cover an interesting topic here today. He's going to be talking about Grails code that you would not believe. So during this presentation, he's going to walk you through some code examples and demonstrate how to adapt them to best practices. So you're going to see code examples that you should never, ever, ever write, along with some alternative solutions that'll significantly improve your current applications or applications that you will be writing in the future. So like I said, thank you again for joining us. We've been doing these webinars and we're really excited about the turnout we have. You guys have given us feedback, and we're always looking for more feedback and on topics that you want to hear about. So please feel free to send that over to us. And then you can learn more about any other upcoming training workshops and webinars that we have coming up if you go to ocitraining.com. And then I know that it will get asked later, so I'll go ahead and put it in the chat. But we will send out a recording of the webinar, and we'll probably send that out by midweek next week, so you will get that as well. So at this time, I will turn it over to Ivan, and he will start telling you about things that you should never do with your Grails code. All right, thank you.
Thank you, Jen. Can everyone hear me? Okay. So, welcome everybody to this session. I've seen Grails code you wouldn't believe, or how to properly write maintainable Grails applications. Before going into any details about this talk, I want first to introduce myself very quickly. I'm Ivan Lopez, and I joined the Grails team at OCI almost 2 years ago. I've been using Ruby on Grails for, I think, more than 8 years now. I'm the organizer of the Madrid Ruby user group. I'm based in Madrid, in Spain. And I also organize Grails, which is maybe most of you are aware. It's a conference about Ruby and the whole ecosystem. And that's all. So now that you know a little bit about me, let's talk about the talk, right? So first, I have this disclaimer, and I need to read it. So this is a true story. The events depicted in this talk took place in some projects in 2017. At the request of the survivors, the names have been changed. Out of respect for the dead, the rest has been told exactly as this occurred. Because, yes, different with Fargo, this is a true story. But please do remember that at the request of the survivors, all the names, classes, variables, method, everything, all the code that you are going to see, I've renamed and changed everything. But out of respect for the dead, I'm telling exactly everything as it occurred. So over the years, I've created a lot of Grails application, and I've learned things that work and things that don't. Also, I've seen a lot of code that could have been done in a different way, making it more readable, more maintainable, or easy to modify. So the idea behind this talk is to show you a lot of examples of how to not do the things, explain why that particular code is not so good, and how you can improve it, and why does it matter. So I'll be happy if after this talk you go home, you go to your work, and change how you develop your applications. Don't worry and don't be ashamed if you see here some of the things that you are doing now in this talk. The point is to learn why they are not the best approach and how you can change them. And before I start with the examples, I have another disclaimer. I don't have the magic recipe to write better code automatically. You'll see that in most of the examples, we, the developers, need to do the effort and do it right. So everyone knows that the larger a class is, the better, right? So in this first example, I want to show you one of the things that you can never do no matter what. This class is a controller, and as we all know, we put all our business logic in controllers, right? No, of course we don't. We don't do that. That's why we use and we have services. So the second thing that is wrong about this class is that there are 15 dependencies, 15 being services injected. So what could possibly go wrong with this? And the final thing, as if it wasn't enough, is that the controller has almost 4,000 lines of code. So the problem here is that you don't need to have a user controller, a car controller, and put everything related to that user or to that car in that same class. You can create more classes. You can create a user detail controller, user registration controller, user notification controller, anything you want. It's free to create new classes. So please don't do this and write this very large class, right? And what can be better than the 4,000 lines class, right? A very large method. So this is the index action of the previous controller, and it has 238 lines of code. And maybe you are thinking that is not too much, right? Well, actually it's too much. And I have some stats for you about this specific index method. So the first one is that there were 41 if and 16 else branches in that index method. There were up to 5 nested ifs. This means that we have one if and another one inside that, another, and finally another. So 5 nested ifs. There were 19 service calls in the index action. So this means that this method was doing a lot of things. 12 dynamic finders to get some data from the database, 87 access to the params variable, and last but not least, and actually the best thing about this specific method was that there were 0 tests, because it's actually impossible to test this kind of code. Think about how many tests do you need to write if you want to cover all those 41 if branches. You can't, it's impossible. And the same happens with all those 19 service calls. You need to mock a lot of things, so please don't write this kind of code. And to continue with the larger the better series, the larger a setup method in a test, the better. If you use Spock, and you should use it for your test, you know or should know that the setup method is shared among all the tests in the file, right? So this is a unit test for a controller, and the first thing I saw, the first time I read this code was something like this. It seems that they were injecting in that test a lot of services. But as you know, in a unit test, we don't have dependency injection. So all those services will be null when we execute the test. And then you continue reading the test, and you realize that this test is creating a lot of shared data. So imagine that you need a car, a user, a book, an author, whatever. So anything they needed, they were putting it here in this setup method. And the thing is that all those objects were available for all the tests. And then in this part, they were mocking all the dependencies in the same way. And the problem is that all the dependencies are initialized exactly the same way for all the tests in this specific file. So I know again that what you are thinking. So maybe you say, okay, it's not that bad. I have some kind of shared setup, and maybe this is only used for a few tests, this spec, so it's not a big deal, right? Well, let me show you this. There was 129 tests in this specification file, and for all of them, the same setup data was created, and all the injected and defined services were mocked in the same way for all those tests. And I don't know about you, but when I code, so when I'm writing tests, I need different behavior for my collaborators. So sometimes I need to return an empty list, sometimes only an object, or maybe throw an exception. So doing this for all of them, for all of those tests, can only lead to not properly test all the code. And what is even worse is that you can also have side effects, because anytime you modify something on that share setup method, you are affecting all those 129 tests. So maybe you just add a new user, a new car, a new book, anything, and you may break, I don't know, 50 different tests. So how we detect all the problems that I've explained? The first thing is that if you can test your code, or if it's too complicated to test it, you should have some kind of alarm or a yellow flag in your head saying, maybe this code is not very good because I can test it. Another thing is that maybe your IDE is slow. Opening that 4,000 lines controller in IntelliJ takes time. I mean, opening the file is instantaneous, but then IntelliJ needs to read the file, get all metadata from the methods, variable, etc. So every time I opened that file, my CPU went 100% of usage, and everything was really, really slow. So if your CPU is always busy, maybe you have problems with the length of your classes. And because another way to detect it is because you have big setup methods with because of a lot of dependencies. So if you see that you need to, if you see that big setup method, a lot of dependencies there, maybe you need to think about how to fix it or how to change it. You can split that class into any other classes. So how do we fix this? Just write small classes. It's free. So we don't need to pay something like €5 every time we create a new class. It's way too better to have more classes that are small, with a small behavior, less functionality, that are really large class with everything there. Also write small methods with good names. You can create private methods, you can create helpers, but please don't put everything on a 200 lines controller or service method action, right? And also write small or even better non-existing shared test code. The setup method should be really, really small, or even better, you shouldn't have to write that setup method. Or if you need it, use it only for some kind of infrastructure things. But please don't use it to define all your mocks there, because that behavior will be applied to all your tests in that specification file. And why does it matter? It matters because we want to write clean and maintainable code. And in all the previous examples, the code wasn't clean and wasn't maintainable at all. It was actually a nightmare to modify that code because it was, you saw, a lot of very big classes with 0 tests. So that's not clean and that's not maintainable. And because we want to be able to test the code, and that code wasn't impossible to test. Remember, 41 if branches in this action. So let's continue with the next example. You all know that the fastest way to solve a problem is copying and pasting everything without thinking twice, right? And you have extra points if you copy something from Stack Overflow without really understanding. So this is a constraints method from a domain class, right? So let me help you to really focus on the important part of the code, which is this one. There is a custom validator that checks the length of a property, and if it's greater than a value, it returns an error message. And maybe you may think again, okay, Ivan, it's not that bad. It's the same code 5 times in a file, right? So I think we can live with that. Well, it's not. It's actually bad because the same code was used 30 times in 14 different domain classes. And this is a problem, and because we are basically copying and pasting the same code over and over. And what I did to solve this problem was creating a class. I call it was a helper class, a Pogo. I call it custom validations. You can use the name you want. It's just a Groovy class. I define there a static method, and then inside this validate length method, the only thing you need to do here is return the closure with your validator. And that's all. And now you can use that validator in all of your domain classes. So now that you have the logic in one place, you don't need to modify all the domain classes again in the future if you decide to change that validation logic. And of course, can write tests as I did for my custom validator, right? So how we detect this pattern? If you see a lot of duplicated code, think twice about how you can fix it and about how to avoid this duplication. And how do we fix this? Just don't repeat yourself. I use this rule. If I need to copy and paste the same code more than twice, then I extract, refactor, and reuse. I allow 2 duplications because sometimes it's better to have a small duplication on your code base than creating the GORM abstraction. Sometimes you are not sure about how the code will be in the future, so you can have a little bit of duplication because maybe in a month you will have a clear picture of how to do that. So it's not that bad. But for the previous example, it was obvious that that wasn't the right way to do it. And why does it matter? Because we want to change the code only in one place, and we want to reuse the code. And if we copy and paste the code in a lot of different places, we are not reusing it. This is one of my favorites because being a Groovy developer is so fun and easy that you don't even need to think twice and about types, right? You can just use def everywhere because YOLO, you only live once, so who cares about types? And then you have this. This method is from a service, and as you can see in the signature, everything is final, which is good. But what about the types? We have this item instance, current params, and current user. And I can assure you that in this particular project, the item instance thing, or the original thing, remember that I renamed everything, it didn't exist. There wasn't a concept name item in the project. So this item thing didn't exist in the project. So when you read this signature, you have no idea about what item instance is. Then you have current params. Well, who knows? And finally, we have this current user, which is probably the Spring Security user. And what about the return type? It's def again, so it can be anything you want. It can be a Boolean, an item instance, a list, null, a string, whatever you want. And then, finally, all these variables are initialized at the very beginning of the method. And again, you don't know about types. Maybe action list or status list are lists, hopefully. And also, the default value was bad because for a list, it's safer to use empty list instead of defining them as a null, because you can avoid null pointer exceptions. So how to detect this kind of code? With code reviews. It's really important to have code reviews because maybe you have a bad day or that day you have everything on your mind when you were writing the code and you just think, okay, def everyone is fine. But then when one of your colleagues reviews your code, that colleague needs to really understand your code, and without types, it's really complicated. So how do we fix it? Always write your method signatures as in Java. We are Groovy developers. We can use sometimes def, but it's really, really important to use the types in the method signatures. So for a local variable, if you write something like def user equals new user, maybe it's fine. There, in that case, use def. But if the type is not obvious, just write it. It's not a problem. If you are dealing with a third-party API library or with a code that is not clear, the return type, just put the type. No one is going to blame you for writing types. They will blame you for using def because reading that code will be more complicated. And this matters because we want to be able to read the code. And in the previous example, those first 10 lines of code were using def. So we don't know anything about the types of those variables. We also want to help our IDE to help us. So with types, we have refactors, we have autocompletion, we can use the IDE for search. And without types, even using IntelliJ, it's complicated. So use types to help your IDE to help you. And finally, because you want to help your future you and your team to read and to understand the code. Because if you are working in a medium big project and you start using def everywhere, I can assure you that in 2-3 months, you won't be able to maintain that code. It will be really, really complicated because you don't know anything about all those types. So please don't use def everywhere. And this is like def everywhere, but with strings. Why do we need to use types when we can store anything in a string, right? We can store a date, we can store a number, a Boolean. So using strings everywhere is right because we can store whatever we want, right? Well, it's not. So in this particular project, what I was searching was for two different constants that are key, core, and core concepts in that application. But those key concepts were used as a string all over the project. So every time the developers needed to access one of those core concepts, they use that concept, that word, as a string. And this is wrong. So we can detect it again with code reviews, and we can also use, for example, CodeNarc. CodeNarc is a static analysis tool for Groovy, and there is a rule to detect this kind of magic strings. And we can fix this using an enum or constants. And that's all. It's really simple. In any place that you need to use that magic string, just don't do it and use a constant. And if you have different values, just create an enum. Think about, for example, a user. You can create a status enum with the different status for a user. Maybe they are active or enabled, deactivated, expired, whatever you need. Put all those values inside an enum. And if you use an enum, hide all the behavior inside that enum class, writing a static helpers method to check the status of your enum. So you shouldn't expose the values. I mean, you shouldn't use those values outside your enum for doing checks. For example, what happens if I want to check if a user is active? So instead of writing from in any place of my code, if user.status equals enum.active or user.status equals enum.whatever, instead of writing that, write a helper method, a static method inside your enum. For example, is user active? And then you pass the user as a parameter or the status as a parameter. So in this way, you have all the logic in one place. You can test it properly, and if in the future you need to add a new value that is also this use for active users, you don't need to change that in all your code. You just need to add a new value to that check, and then add new tests, and you're done, right? And this matters because we also want to find usages of the constants. And if you have an enum or a constant, you can do it. Your IDE will find that for you. But with a string, it's really more complicated, especially if, as I showed in the example, that's a core concept in your project and it's used everywhere. And also because we want to refactor the code. And with a constant, we can easily check all the places in which that constant is used. But with strings, it's really more complicated. Okay, next example. This is another pattern that I've seen a lot, and it happens because it's really simple in Grails to just write a dynamic finder to execute a query in every place in the application. So folks do it every time they need it and in every place that they need it without thinking twice. So if they need to write something like user.find all by last name here, I do it. And if I need it in another place in my application, the same dynamic finder, I write it again. So the problem is something like this. Here I'm looking for find by and find all by ID in all the services in this specific project. And there were almost 400 occurrences. And maybe again, you are thinking that this is good because we should put the business logic on the services. So maybe this is not that bad. The problem is that in this particular project, everything, so this kind of the simple dynamic finders queries were spread all over the code. The same query again and again. And it is even worse because here I'm looking for find by and find all by in controllers. And it means that In controllers, you are querying your database to get some data, and you shouldn't do that on a controller. You should do that on services, because this means that you are executing some kind of business logic. Sorry. And finally, it's even worse because you are executing here dynamic finders in a GSP file, meaning that when you are rendering the HTML, you go to the database to get some data, which is absolutely wrong. If you need that, pass all the information you need to just GSP, but please don't do this thing. So we can detect it with code reviews. You are going to see this a lot of times. So remember my second disclaimer. I don't have the magic recipe to write good code automatically. You need to put on your site. But you can fix it. You can create a new layer. You can call it repository service, GORM service, whatever you want. And in this kind of special layer, well, it's actually just a Grails services, but you as a developer treat them, this layer in a special way, because you are only allowed to access the database in this kind of repository services. And it doesn't matter if you only need to write just a dynamic finder, a safe, or a complicated criteria. Every time you need to write code that needs to go to the database, you put that code in this special repository service layer. And this matters because we want to decouple our code from the persistence. I'm not talking here about maybe removing GORM in the future and replace it with another persistent thing. I'm talking about having all the database access code in one layer. With this, what we can do is write integration test for those repository services or GORM services layer to make sure that all our repository or our persistence is working. And then in the rest of our code, when I need to access the database, I use my repository service layer, and the only thing I need to do is write a unit test and just mock that repository service and return whatever I need. An empty list, a user, a book, a car, anything. And that's all. And having all the database logic in those special services allows you to do that. You have a separation of concerns, and you write clean and good code and differentiate between integration and unit test. Because most of the tests that we write or to test most of our code, we can do it with unit test. So we can really have two different kind of tests: integration test for all our persistence to make sure that it works, and then use unit test for pretty much everything in your application. So if you are a Java or a Groovy developer, you have experienced a null pointer exception for sure. But yes, life is too short for null pointer exception. So what we can do about it? In Groovy, we have the null safe operator, which is amazing if you use it properly. But the thing is that folks don't know how to use it. So let me explain this. Here we have book.findById. So book is a class, it's a domain class, a Grails domain class, so it can never be null. But the developer put here the question mark, the null safe operator, because who knows, maybe there is a bug on the Java compiler or the Groovy compiler, who knows, right? Then they get this updated book, and in the first three usages, they access to the book with the question mark again to protect against null pointer exceptions. But then they use updated book.refresh without the null safe operator. So if updated book was null, here we have a null pointer exception. Then we have this catch book status. That thing was a concurrent hash map that was defined and initialized in the same class, so it can never be null. But again, the developer put here another null safe operator. Here we have this lone level, which is an enum. So again, it's a class, and full was one of those values. And here we are using or abusing again of the null safe operator because a class can never be null. And finally, we have here on the second line, you define this final WS thing, which is a list. and you use it on the bottom again with the question mark because who knows. So maybe you think that this was the only place in this code in which they were abusing that much of the null safe operator, because this method has all the wrong things that you can do with the null safe operator. But that's not true. In this project, the null safe operator was basically spread all over the code. There were hundreds of examples like this one. So how we detect this? Code reviews again and again and again. It's really, really important to have code reviews. And you can also use CodeNR. There is this rule, unnecessary safe navigation operator, that will warn you when you are using the null safe operator and you shouldn't. The problem in this particular project is that I think they were using CodeNR, but they didn't pay attention to it. So it doesn't matter. You have something that warns you about your code quality, but you don't pay attention. And how do we fix this? Just only use the null safe operator when values really can be null. And more important, think twice before using it. If you are writing some kind of code and you have a null pointer exception, the first thing that you can try is just put the question mark and you're done. But instead of doing that without thinking, you should think why that this null pointer exception is happening, because maybe the problem is not in that particular line. Maybe that variable can't be null, and the problem was in the caller method. So if you put here in that line the question mark, you are just hiding the bug in another piece of code. So think twice before just using the null safe operator. And this matters because, again, we want to write easy to read and maintain code. And if you use the null safe operator all over your code, you don't know about your code. And it will be really complicated to read it, because when you read that code, you are not sure if something can or can't be null. So it's complicated to maintain that kind of code. This is another pattern that I've seen a lot. In Grails, we have this thing called params in the controllers. So params is like a map. And in Grails, we use that map to put all the parameters, or Grails use it to put all the parameters after doing the data binding with the HTTP request. And the pattern that I've seen is that we receive that params in the controller, we modify them, we add or delete a lot of things in the params, then we pass the params as a parameter to the service. We use params again, modify the params in the service, return the params to the controller, modify it again with another values, and finally we render some response with all those params. And this is really, really grown. So in this particular project, they were passing params to services in 219 places. And this is grown because params is a map, so it's like a box. You can put anything you want in the box, and then you pass the box to the service. But the thing is that you only see the box. You can't see what's inside the box, or at least you can see it until it's too late. So when you read the method signature, you don't know, again, anything about types or about the things that you expect to pass or to receive. So don't use params for that. For receiving arbitrary HTTP parameters, they are good, or at least they are not bad. We will see how we can fix that also later. But for passing something to the service layer, don't do this, please. So we detect this again with code reviews. So if you see some code that pass params to the service, talk to that college, ask why, because it should be another option to do this. And just to fix it, just don't do it. If you think that you need to pass params to the service, don't do it and think twice. So you can, the first thing is, for example, using types. So write types in the method signature and instead of just defining params. And what I like to do is write static inner classes in the service, and I annotate that classes with @builder. And with the @builder annotation, we have a really nice way. So @builder is a Groovy annotation. It's not related to Grails. And with this annotation, we have a really nice way to create instances and set and define all the values that I need as a parameter. So when one of your colleagues sees this whatever input thing as a parameter, this static class, she can go to the definition and just see all the types there, right? So you can see that there is a string, an integer, and a date. So she really understands what the method accepts and needs as a parameter without reading all the code in the method. Because with params, you need to read all the method and find for usages of params to really understand all the parameters you need to pass. And if you see something like in that service method params.user, you don't know if it's a user instance or it's maybe it's a string with the username. You can't be sure. So this matters because the params belongs to the controller layer. So params are just a thing, a helper that we have with Grails to access all the HTTP parameters, but they belong to the controllers layer. And we want to decouple controllers from services. So if we pass params to a service, we can't call that service from another service because we don't have params. So what we do is we create a map, which again is a box, and we put everything there. And that's really grown, and it's complicated to read and maintain because remember, a box, you can't see anything about the types there. And speaking about params, who need common objects, right? Because we have params for the win, right? No, please. So for those of you that don't know about common objects, so a common object is a pogo or a plain old Groovy object that implements the validatable trait. In Grails 3, in Grails 2, you need to annotate that pogo with that validatable. And basically, you use that class as a parameter in your controller actions. And with that, Grails, we do all the data binding and all the data validation using that class for you. So in this project, you can see that there are almost 2,500 occurrences of params in controllers. And this happened because in this project, they were not using common objects or in most of the places. And then when they were using common objects, they were using it in the wrong way. So because a common object should be defined in the method signature, and as you can see here in this update vehicle action, the method signature is empty. And then here you see the pattern again. You modify the params based on another parameter, or you go to the database, build the status.find by ID, whatever. Then here you use a common object, but you are using it in the wrong way because you instantiate the common object here, you call the bind data method, and then you even modify the values after the binding because maybe, I don't know, you are not sure. So this is growing, as I said, because Grails can do all this for us. And finally, what happened here is that we are passing params again, and also the common objects to the service. So you have more extra points for doing things wrong. Because just defining this update, so this vehicle command or this vehicle detail command on the method signature, just doing that, Grails will instantiate the common object for us, will do all the data binding for us, and we don't need to do anything. We don't need to write all this code. So we need to detect. So for detect this, we need to use code reviews. There is no magic recipe for this, and we fix this just using a common object. It's really important, and never use and never modify params, because remember that params are just a box. So imagine that you have, for example, this user form to create a new user on your application. So you need a username, last name, password, date of birth, 8 different parameters. If you use params on your controller, you don't know about the parameters, you don't know about the types. So you read the code and you only see params. If you create a common object and you define all those parameters in the common object, then in the future, if you need to read that code, you just go to the command object and you see, okay, the name is a string, the date is date of birth, it's a date, age is an integer. So you can see the types and the names of the parameters that you expect. And this matters because you can know exactly, as I said, the names and the types of the parameters. And with a command object, you only need to read the class, and that's all. And it's even more important. So even more important is that you can test the data binding and all the transformation and validation with unit tests in your command objects. You don't need to move all these things to a controller, which will be more complicated. All the logic and tests related to the data binding and validation, they are defined on the command object. And in your controller, the only thing you need to do is call command.isValid or command.hasError. And if there is an error, just return some kind of error. And if not, you know that all the parameters are valid. So you can now call command.username, command.whatever, and use those parameters and pass them to services. So everyone knows that the business logic belongs to controllers, right? No, it doesn't. You need to put your business logic on services. But the problem is that when you put your business logic on a controller, eventually you will need to save data to the database from that controller. And because your logic is there, you also are going to need, when you go to the database, to have a transactional behavior. So at the end, you annotate your controller or your action with a transactional annotation. And you also have extra bad points if you also do a save flux true. So this is wrong. So please don't do something like this. In this project, I'm looking for a transactional in all the controllers, and there were 208 actions annotated with a transactional. So this means that in all those places, there were business logic. And this also means that all that code can't be reused because we can share it because it's on a controller. So if we move that code to a service, we can reuse it, right? 208 actions with business logic there that can be reused. So we detect this again with code reviews, and also we can use CodeNarc. There isn't an out-of-the-box rule for this, but CodeNarc has this mechanism to create custom rules. And actually, it's pretty simple to create one of these custom rules. So you could create one to detect the usage of a transactional on controllers. And if there is some action or controller annotated with a transactional, then CodeNarc will warn you and the bill should fail. So we fix it, just putting the business logic on services. That's all the thing you need to do. So if you think that you need to add a transactional on a controller, don't do it and move that code to the service layer, and that's all. And this matters because we want to reuse the business logic, and we can only do that if it is defined on the service. In a controller, we can't reuse anything. And because the HTTP layer and the controllers belong to the HTTP layer, it's not the place for the business logic. It's the same thing as if you use or pass the HTTP request or the response to a service. If you do that, then you are coupling the HTTP request with your service. And that service or that specific method can be reused from another service in your code because you don't have the HTTP request there. Or maybe you have the request because you are passing the HTTP request all over your code, which is, again, not the right way to do it. I'm pretty sure that you have heard this phrase, tests are for people who write bugs, but as I don't write bugs, I don't need to write tests, right? So let me tell you something, you are wrong. You need to test. You need to write tests. You need to make sure that your code works, that you can modify it without breaking it, that you can add new features, you can do refactors, and everything is still working. And then you find this kind of code. This is a screenshot, and the comment is pretty amazing. It says, this is not used yet, should be fine, but no tests. So this means that you spent time writing that code, you know it's not used and it's not necessary, and as you know that you don't need it, you don't write tests. So what are you doing? Why did you write this code, right? And as you can see, at least in this case, the comment is true. The name of this method, do stuff, is in light gray color in IntelliJ, meaning that the method wasn't actually used. So the best thing that you can do with this code is just delete it. It's not used, it's not tested, nobody cares. And also take a look at the second parameter, incoming params. Again, another map, another box. So how we detect this? With code reviews. We can also use coverage reports. We can use the Cobertura Gradle plugin, and with this plugin, we'll generate these coverage reports. So after we pass all our tests, we run the coverage report task, and we open the report, and maybe we can take a look and see, okay, why this class has only 12% of coverage? Let's fix it. Let's write more tests for this class. How do we fix this? Doing TDD. If you do TDD, test-driven development, you will always have tests, because with TDD, you first write the test and then you write the code. But if you don't do TDD, or you don't like it, or you don't feel comfortable doing it, it's not a problem. Just write the code, then write the test, and just don't push code without test. It's actually pretty simple. And this matters because we want to be able to modify the code, we want to do refactors, and we want to add new features and without test, you can't sleep well at night. And I do really like to sleep well at night without worrying that my code maybe it's going to break production next Saturday at 3 a.m., right? So in case you have any question or any doubts regarding if you should write tests or no, I have created a really simple decision tree to help you. So should I write tests? Yes. Okay, what if I just need to finish something really fast because, I don't know, it's Friday afternoon and I'm going 2 weeks on holiday and I need to deploy this on production before leaving. So in that case, do I need to write tests? Yes. And what if I just, oh my God, please write tests. Always write tests. You don't have any excuse for not writing tests. And now let's talk a little bit about URL mappings. The default URL mappings in Grails are great because you just write a controller, an action, and you're done. The action is exposed automatically and you don't need to do anything. But the thing is that having this, when you start a project or when you just need something quickly, is good. But when you have a project with quite a few controllers, keeping the default URL mappings is a nightmare because you open the file, you take a look at the URLs, the controllers, how they are mapped, and there is nothing there. You don't know about the project, about the URL structure. It's really complicated to have a good overview of the project without the URLs. So please don't do this. I've seen this in a lot of projects, big projects with hundreds of controllers, and it's really a nightmare to just take a look at that project. So to detect this, again, you need to use code reviews, and to fix it, just delete the default mappings. Create manually a mapping per controller action, and that's all. And if you have a lot of mappings, it's not a problem. You can create more than one URL mapping file. You don't have to put everything in one single file. You can create as much files as you want. User URL mappings, book URL mappings, whatever you need. And this matters because having all the URLs in the application in one place or in 2 or 3 files, it's what we want because we don't want to expose, we want to expose only the actions that we define explicitly because if you don't do that and you keep the default URL mappings, any public method on a controller will be exposed by default, and probably this is not what you want. So this is my last example because I've kept the very best for the end. I call this the masterpiece because it has so many things that are wrong that it's amazing. Let me explain it really, really slowly because I really want you to understand this code. So don't worry about the font size. I'm going to zoom in and explain everything. So first, let's pretend that we didn't see this signature because it has 7 parameters. So maybe we can probably do this in another way. Then we have this code. It's the same code 6 times. So what I'm going to do is I'm going to zoom in this line. Here we are using companies, subdivision, regions, this kind of domain objects. Remember that I renamed everything, right? And this code is doing the same for all of them. So let's zoom in into companies. So we have these string companies. So the result will be a string. At least it's not def, so good. And then this company list is a list of company, which is a company is one of those 7 parameters on the method signature. And a company is, in this project, is a Grails domain object. And so remember in this project, or in the renamed version, I have companies, department, division. All those 7 parameters are lists of domain objects. And here in this example, we can see again the abuse of the null safe operator. Because if you don't have values for a list, you should pass an empty list instead of null. So you don't need to use here again the null safe operator. Then we execute this .id, and here we are collecting and extracting the IDs of the domain objects in the list. So if we have, for example, a list with 3 companies in this particular point of the code, we have something like this, a list with the longs, in this case, with the 3 IDs of those domain objects, the long number 2, 5, and 7. Then we execute .toString, and the first time I saw this code, I was thinking something like, this can't be true, this can't be true. So what I did, I put a breakpoint, I debugged the code, and I thought, oh my God, it's true. Because this toString method is not executing a collect. Here we are not converting the numbers 2, 5, and 7 to the string 2, the string 5, and the string 7. What we are doing is getting the string representation of the list. And I mean this specific string. Bracket, the 2 as a string, a comma, a space, the 5 a string, comma, space, 7, a close bracket. That string, right? And then the next thing, when you have that string, you need to remove some kind of a string. So you remove the first open bracket. So you have now this string without the open bracket. Then you remove the close bracket. So you have now this string. Then you remove all the spaces. So here you have the string 2,5,7. Then you trim it because maybe there are more spaces. Who knows or who cares? So at the end, you have this string again, 2,5,7, and you were doing this in these 6 places for all the different parameters in the method signature, right? So after this, we continue with the code. We have here this statement, select count star as counter from insurance policy condition where. We are using a multi-line string because who knows? And then again, 6 times the same kind of the same pattern in the code. So let's explain this for the companies, right? So remember, this company list is from the method signature, is a list of domain objects. So here, instead of doing this, if you use the Groovy truth, you can write this code just as if company list. Right, this is the method on the variable on the method signature. And then here we build a SQL query concatenating strings. So what could possibly go wrong with this, right? And then finally here, we use the string with the values that we calculated in the previous step. And of course, remember that we do this in the 6 cases for departments, subdivisions, regions, whatever, right? Then we remove the first and in that string, because imagine that this is the query that we are going to execute. Select count star as counter from whatever, where, and company ID in. That first and shouldn't be there because that's not a valid SQL statement. So we remove that first and to create a valid SQL statement. Then we continue with the code. So here we have this check. We first initialize the statement with that string, and then we check if it's empty, which can never be, so that if it's actually not used, it's not needed. And then we execute that query to get the counter. And what happens if all the lists in the method signature are empty? What happens is that we are going to execute the query, select count star as counter from insurance policy condition where, and that query is not valid because it ends with a where clause, right? So this code, as you have seen, was grown in so many different ways. So what did I do to refactor this code? Well, actually, it's not a refactor, because using the word refactor means that there are tests, right? And as you can imagine, there were no tests for this code. So I rewrote that code and created the test. So I kept the signature because this code was used in a lot of places. I don't know why. So I didn't want to change all those places. The only thing I changed in the signature was the integer, the return type, because we are returning the count of the elements. Then I use domain class dot create criteria dot count, and inside this criteria, what I did was something like this. If company list, I add a new condition. Then I did the same for all the parameters, and that's all. The only thing I did here was using GORM the right way. I didn't concatenate the strings and all those kind of strange things to fix this. And this option, it's way too better because we use GORM. We don't need to worry about concatenating strings, about nulls, about extracting the IDs in that strange way, right? So this kind of code, it's impossible to detect it without code reviews, but we can fix it. We can teach the developers their tools, their languages. In this case, they didn't know too much about Ruby, about Grails, about GORM. So we need and we can teach those more junior developers to use all the tools and all the powers, all the things that they have with the framework or with the language. We can mentor them. We can buy books. We can send them to conferences to learn about these tools that they use every day. And this matters because we write clean and maintainable code. And we also want to, this matters because we want to help your team to grow, to be more expert in the framework and in the language that they use every day to create applications. So that was all. I hope you will enjoy with all the examples and learn something new today. We've seen a lot of examples of things that we should avoid and how we can detect and fix and why they matter. And I want to finish with this quote. With great power comes great responsibility. We are developers and we can make things different. We just need to make sure that we use our powers properly. So thank you very much. If you want to learn more, you can go to this URL, guides.grails.org. There are now more than 80 guides with a lot of examples, companion repositories with those examples to do a lot of things inside for Grails. You can also go here. There is a link for the Slack, and most of the Grails team, we at OCI are pretty active in that Slack, helping folks with their questions and how to write better Grails applications. You can also go here to check the documentation. There are links for the documentation for the framework, for GORM, the views, profiles, testing, a lot of things. And you can also check these links. So in the first one, we have a list of the events, meetup, conference in which we are going to talk. And we can also offer training about Grails, about now Micronaut. So if you need help with your Grails applications, with your Micronaut applications, if you want to migrate your Grails 2 to Grails 3, if you want if you need help, we can help you. And I think that's all. Thank you all very much for listening. And now I think we may have some time for questions.
Yeah, so we haven't had any questions come through on the chat, but if anybody has any questions, please feel free to put them in the chat, and we can ask Yvonne out loud, or if nobody has anything, we'll just stay on here for just a couple more minutes before we close things out. Thank you guys again. I hope you enjoyed it. And yes, we are recording this, so we will send it out to everybody. You'll probably get that midweek. It does take a while for the recording to upload, and then Zoom will send it to us, and then we'll send that out in a follow-up email.
So I can answer the question. Does it mean we can use command objects in place of param completely? Yeah, the answer is true. Even if you only are going to do something like, imagine that you only need one parameter, params dot name. Maybe you can do it now because you think, okay, it's only one parameter, I can do that. But the problem is that maybe in 3 months, you will have 3 more parameters. So it will be more complicated to change it after 3 months. So just always use command objects. Yeah, you don't need to use params. You can always create a command object.
And then there was one, wondering if you could talk a little bit about inner statistic class in @Builder.
Yeah. So what I did for one specific project was inside the service, we created a static class. We call it input, and we annotated with a builder. And in that class, we defined all the parameters that we needed for the method. And that's all. So with a builder annotation, you can create a new instance saying, imagine that you called this input class. So from the controller, you do input.builder, and then you have a lot of methods created automatically for you. So imagine that you have a name and last name. So you do input.builder.name, you define the name, .last name, you define the last name, and finally you execute the .build method to create a new object, and then you pass that input object to the service. So if in the future you need to add a new parameter, the only thing you need to do is modify that class annotated with a builder, define the new parameter, or set the new parameter in the controller, and then use it on the service without modifying the signature and without doing anything else.
Okay.
So URL mappings. Yes, so the question is if I'm explicitly suggesting defining all the URLs mapping for the entire application. Yeah, that's what I'm saying. So maybe you are thinking that you have a lot of controllers or a lot of actions. So maybe you can define, if that's too much for you, maybe you can define 1 line per controller. But for me, it's better to have a lot of there that maybe expose an action that I don't want, or maybe I'm not aware that I'm exposing that. And when someone joins your team, you can take a look, or that person can take a look at the URL mappings and can really understand how your application needs some kind of structure.
And Robert was wondering what the best way to write a simple create operation that brings up a form to fill in the object properties with the save button. Do you need 1 action or 2?
I think you only need 1 action for the post method. So you can define a command object with those 2 properties and just map that to the command object that you define in that action. I think there is a guide, a Grails guide in that URL about something like this. So for example, to upload a file, you need to send the file and maybe the name or something like that. I think there is a guide about that.
Okay, so when we send out the recording, we can include the link to the Grails guide. How about that?
Yeah. Okay.
And it looks like, is it okay to look up domains in command objects or controllers, or should that be avoided due to @transactional issues?
I don't like to do that. This is so I don't have the actually the real answer. So maybe the answer is it depends. So you need to talk and decide what you want to do on your team. Because sometimes it's not that bad, sometimes it is. So it depends. Maybe if you only want to execute a dynamic finder using the other thing, but I don't really like because you are actually mixing behavior in different places.
Okay. And we'll go ahead and answer maybe one or two more here, and then we can try to maybe put the answers to the rest of them in the follow-up email. It says, is there a transaction path with CodeNarc if you have a bad test coverage today? Can you use it slowly transaction to TDD?
With CodeNarc, you can, so it's not going to help you that much. So because CodeNarc is going to help you to write, so probably more idiomatic or more better code, but it's not about writing tests. So if you want to write tests or increase your coverage, just start writing tests, and you can use this the Cobertura plugin that I mentioned to take a look at the reports and really understanding all the places in your application that you need to write more tests.
Okay, and then the last one we'll do is, are all public methods in a service transactional by default? And what about private methods?
By default, I think this change between Grails 2 and 3, and also I think with the latest version, with the latest GORM, by default, they are in Grails 3, they are not transactional. So if you want to make all the methods transactional, you need to annotate your service with the transactional annotation. And about the private methods, as they are called from another public method in that class, the transactional by default will be so they will use the same transaction defined before. But you can change that if you want.
Okay. All right, everyone. So we'll go ahead and capture the rest of the questions here in the chat, and we'll get those answered for you and put them in the email that we send out with the recording. We hope everybody enjoyed the webinar today. And thank you again, Yvonne, for tuning in and giving us that wonderful presentation. We'll talk to you guys next time. Thank you.
Thank you. Bye-bye.
Bye.